Hi, welcome back to Chemistry at Glance. My name is Aneta, and in today's videos we're going to practice some bond enthalpy questions. So this is our first question. It has two parts. So the first one says, write an equation to represent the standard molar enthalpy change of formation of H2O, so water. So the first thing you want to do is write H2O on the right hand side. And then just think about how water is formed. So we need hydrogen, which always goes in pairs, and oxygen, which also always go in pairs. We also need to balance the equation. So we've got two hydrogens on the left-hand side and two hydrogens on the right-hand side, so that's balanced. Well, we've got two oxygens on this side and one oxygen on this side. So what you want to do is just write half in front of here. So we've got one oxygen on either side. What you also have to remember is to write the states, the symbols for states. They both gaseous. And let's do the next part. So the standard molar enthalpy change of formation of water is minus 242 kilojoules mole minus 1, using the values from the table below. And this value, this one, to calculate the average bond enthalpy of the OH bond in H2O. So I always take a couple of steps to get to the final answer, to find the enthalpy change. If you're not sure of the steps I always take, please visit my blog, for which I will leave the link in the description down below. So let's do it. So the first step I always take is draw out the molecules. So our equation is right here. So we've got H2 plus half of oxygen. And this gives us H2O. So O and two H's. So the next step I always take is to calculate the average bond enthalpy, for all the bonds broken. So in this example, it's HH, which is 436, and half of OO, which is 496, divided by 2. Which is 248. So the next step is to find the bond enthalpy for all the bonds produced. And in this example, it's the two OH bonds. But we don't know the average bond enthalpy for OH, because that's what we got to find. So I'm just going to write 2OH. So to find the enthalpy change, we always do bonds broken plus bonds created. We know that the enthalpy change of this reaction is minus 242. We also know the bond enthalpy for all the bonds broken, which is 684. And now what we got to add is 2OH. And something I forgot to write, every time a bond is produced, it's an exothermic process. So we have to put a minus, because the energy is released. And then just rearrange. So we can take the 20H over to make it positive. 2 OHs over to make it positive, and we're left with 684 plus 242. So this is equal to 926, and the average enthalpy change of OH is 463 kilojoules mole minus 1. The next question says, explain briefly what is meant by the term bond enthalpy. So all it means is the average value of enthalpy required to break a given type of covalent bond in a molecule of gaseous species. All this means is the average value of enthalpy required to given type of covalent bond is that we've got different covalent bonds, and each covalent bond has a different average bond enthalpy. So bond enthalpy is the enthalpy needed to actually break this bond. All these different types of bonds. Okay, so I've got the next question right here. Calculate the enthalpy change for the reaction by using average bond enthalpies in the table below. So as you can see, the step 1 has already been provided for us. This is the equation drawn out. So we can see all the molecules drawn out. So all the bonds are here visible. So now all we gotta do is find the bond enthalpy for all the broken bonds, because in reactants all of the bonds are broken, so that in products they all can be formed together. So we're going to start with bonds broken. So as you can see, we've got 1, 2, 3, 4, 5, 6, 7, 8 CH bonds. Each CH bond has an average bond enthalpy of 412, so we got to times it by 8. We also have got 1, 2 CC bonds, and it's 348, but we've got to times it by 2. And we've got 5 O double bond O bonds, and from the table you can see O double bond O has 496. The average bond enthalpy of O double bond O is 496, and because we've got 5 of them, we just times it by 5. Then the final answer for all of this is 6,472. Now that we've got all the bonds broken, we have to find the value of all the bonds created, so the products, right hand side of the equation. And because it's an exothermic process, the energy is given out, so our bond enthalpy value will be negative. So we've got 3 of this. If it makes it easier for you, you can draw it out again and again. And now you can see we've got C double bond O bond, and we've got 1, 2, 3, 4, 5, 6 of it. Each of them has a bond enthalpy of 743. So we've just got to do 6 times 743. And remember to put the minus in front. The other bond that we've got is H2O. So again, you can draw it out because we've got 4 of them. And 1 more. And then just count the OH bonds. 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 OH bonds. Each OH bond has an average bond enthalpy of 463 and a minus in front. So the final answer for this is minus 8,162. Our last step is to calculate the enthalpy change. So this is all the bonds broken, this number here right here, plus all the bonds produced, which is this number right here. In theory, it's usually just this number minus this number, because a plus and a minus gives us an overall minus. So what you usually do is just take the number of the bonds broken minus the number of the bonds created. Either way, the answer is the same, which is minus 1690, and our unit is kilojoules, mole minus 1. What you can state from this number is that the overall reaction is exothermic. Another question which says calculate the average bond enthalpy for the C-double-C bond by using the enthalpy change for the reaction below and the average bond enthalpy values in the table. So our steps again. So step 1, draw out. I'm just going to draw it out at the top of the equation here. So we got C, C and 4 H's. This tells us there has to be double bond C plus H and H, and the product C, C, and then we got 6 H's. No double bond C here because carbon is in group 4, so it needs 4 more electrons to be stable, and it has 4 bonds. 1, 2, 3, 4. Right here, it also has 4 bonds. 1, 2, 3, 4. If it only was a single bond right here, I'm just going to write it down to show you. It would have 1, 2, 3 only. So that's not what we need to do. We have to put double bond in here. So now that you've got it all, we're just going to find the enthalpy change of all the bonds broken. So C double bond C, that's something we've got to find. So we don't know this. Then we've got 1, 2, 3, 4 CH bonds, which is 4 times 412. Next thing we've got is 1 HH bond, for its value is 436. So altogether, the value is 2084 plus C double bond C. Now all the bonds created, and this is C, C, C single bond C, and the average bond enthalpy for this is 348. Then we've got 1, 2, 3, 4, 5, 6 CH bonds, so 6 times 412, and this gives us 2820, but we have to remember about the minus, so our number is a minus. So now the enthalpy change. We know the enthalpy change is minus 137. We know that the bonds broken is 2084 plus C double bond C. And now we've add another minus 2820. When we take this over, we get 2683, which is equal to 2084 plus C double bond C. So to find C double bond C, we just gotta take this one over. It was positive on this side, so when we take it over, it's a negative on this side. So the answer is 599 kilojoules mole minus 1. So the next question I've got here for you has 3 parts. We're going to start with the first one. So use the values to these values in the table. These are the average enthalpy change for these bonds. Use these values to calculate the enthalpy change for the direct hydration of ethene. This is the equation for hydration of ethene. They already drawn out the molecules for us, so this is our first step. The second step is to find the bond enthalpy for all the bonds broken. So that's what we're going to do now. So we've got C double bond C bond right here, and the average bond enthalpy for this is 612. Then we've got 1, 2, 3, 4 CH bonds. So we got to do 4 times CH, which is 412. Then we've got 2 OH bonds, which is 2 times OH, so it's 463. We add it all together and get 3,186. Now we've got to do the same thing with all the bonds produced, which is this ethanol. So we've got 1 OH bond, and this is 463, but when bonds are produced, remember, it's always negative, so minus 463. The other thing is we've got single bond C, and this is 348, but we add minus. Next thing we've got are the CH bonds, and we've got 1, 2, 3, 4, 5 of them. So 5 times minus 412. And the last one is the CO bond right here, which is 360, so minus 360. If it's easier for you to remember about all the bonds, every time you count one, just cross through the bond, and then you'll always remember to calculate all of them. So this all is equal to minus 3,231. So the last step we've got to do is find the enthalpy change. So all the bonds broken, 3,186, plus all the bonds produced, minus 3,231. And the final answer is minus 45 kilojoules mole minus 1. So the reaction is exothermic. Don't be surprised if most of the equations will equal with negative answer, because most of the reactions are exothermic. So you're not wrong if you keep getting negative answer. That may just be the case. So the next bit asks us to give a reason why the calculated value in part I is different to the actual value, which is minus 46 kilojoules mole minus 1. So this is because we use the average bond enthalpies, not the actual values that they talk about in the question. Like for example in this, the CH bond, which is closer to the OH bond, will have a slightly different bond enthalpy value than the CH bond that is completely opposite the OH value, but the difference is so small that we use the average bond enthalpies. That's why the actual value will be different to the value we calculate. So, explain whether your answer to part 2, this one, supports the use of average bond enthalpies to calculate the energy change for a reaction. Yes, it does support the average bond enthalpy, and this is because the value we calculated is minus 45, and the actual value is minus 46. This means the values are so close together that the average bond enthalpies are valid for these answers, because as I said, the difference is very small. So just remember, everything I show you are my techniques and ways of learning and revising. If you have any questions about my videos, please comment or email me. I will leave all the links in the description box down below. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. So this is all for this video. Like, subscribe, and see you soon. Bye.